Factoring tricks, sum of squares. In this video, we're going to see what happens when we try to factor a sum of squares. So that would be like when we have a square number plus another square number, or square variables. So one idea that we could try for factoring this and breaking it down into two things multiplied together is maybe we could do a plus b times a plus b. The thing is that when we FOIL this out, like we saw just a couple of videos ago, what we actually get is a squared plus 2ab plus b squared. And this doesn't match. It's not equal to a squared plus b squared. So we could try a couple of different things, but what we're going to finally end up with is we're going to see that there is no way to factor this. It's just not going to work. So instead, what we're going to say is that the sum of squares is always prime. So that means that it can't be written as two separate things multiplied together. So we can say that something like 6 is 2 times 3, but if we look at just the number 3, we can't break that down into two other numbers multiplied together. So when we say that something is prime, that means it cannot be factored. Can't break it down into two things multiplied together. Okay, so let's see what kind of examples we're going to have to do related to this problem. So in example 1, we've got x squared plus 9. So right here we can see that this is a square number. This is just x squared. And this is also a square number. This is 3 squared. So, and then we have our sum in the middle. This is definitely a sum of squares. That means that this is going to be prime. And we cannot factor it. We cannot break this down any farther. So if I told you to try and factor something like this, you would have to say the answer does not exist. You can't break it down any farther. So this is a dead end. Can't factor x squared plus 9 any farther. So let's go ahead and now look at this example 2. Here we've got 32a squared b plus 50b cubed. So this one, I'm seeing right off the bat that these are both even numbers, and I've got a b in both of my terms. So this is telling me that I'm going to have to do a GCF, greatest common factor. And we should really be looking for common factors every time we come to a factoring problem. Make sure you're looking for those GCFs. So right here, I can pull a 2 out of both terms, and I can pull a b out of both terms. And so that will leave us with 16a squared plus 25b squared. So now we can notice that we've got a square number right here, the variable is squared, got a square number right here, and our variable is squared. And we've got the plus sign in the middle. So that is going to be our sum of squares. So remember that this is prime. That means that this part in the parentheses here we can't break down any farther. Therefore, our final answer will just be 2b, that we were able to successfully factor out, times 16a squared plus 25b squared. And that will be our final answer.